In this video, we're looking at how to display numerical data. So starting with dot plots are classic. You know how to do a dot plot, I'm hoping. Few things you need to be careful of with dot plots is like evenly spaced out each like dingo as well as between the dots. So just be careful with that and not skipping numbers even when there's no data. So imagine if we didn't have anything here for 8, we'll still write 8 there. Because one reason of using dot plot is to show distribution. So if we had no data here and we skip these numbers, that's gonna look differently whether we show them or not in terms of the distribution. So it's really important that we do not skip numbers even when there's no data. And then obviously lastly, you want to label things to show what you are displaying. So that's dot plots. Next is stem and leaf plots. The leaf part of stem and leaf plot is going to be the following digits. And the stem is the leading digits. And then you must include a key. I don't know why I put space here, even a space needed. And you can do stem and leaf plots for even decimals. And again, you should not be skipping numbers in your stem, even if there's no data. So let's start with a stem and leaf plot example. So first thing you need to determine when you have your data is not right away, just write down whatever numbers you see, is to think about your key, think about your scale, think about how to group them. So in this scenario, I'll be looking at what is my lowest number. My lowest number is this. And then the highest number that I can see is 7. So then we know pretty safely that we can just go 1, 2, 3, 4, 5, 6, 7. Whereas if our lowest was 1.9 and then, for example, the highest was 27.5, and then we don't want to have 27 numbers here. So then we need to start thinking about grouping them into intervals of 5. So we'll have like 1 to 5 and so on. And if we're grouping them, stem and leaf plot will not be as useful. We might as well use like a histogram. Now this one is good and they're in decimals. So in our key, we should put that we're showing decimals. So for example, if we have 1 and then a little line and then 9, this means 1.9 in our stem and leaf plot, and then we can start constructing the stem and leaf plot. So this process is fairly long and you have to do it carefully by hand. So what I'll be doing is crossing things out. So I know for my stem, starting with 1, there's 1.9. So I'll put it somewhere here to start off with, because I don't know if there's anything before or after. So if I find anything smaller, it should go here. Anything bigger or like same as 9, it needs to go after. And then I'm looking through every number. There's nothing else that starts with 1. Then I'm just going to move this closer to the front. So that's all I have for 1. And then starting with 2, we have 2.4 here. So I'm just going to write 4 somewhere here. And then I also see 5. So put 5 there. 8. Another 8. And that's all I see. Actually, I missed a 9 here. And then I also missed a 0 here. So it really helps to cross things out, making sure you didn't miss anything. And I've somehow put them in a nice order, so that's good. So that's gonna be fine, except that we don't want too much gaps between the here. We want all the gaps to be somewhat even. So I'm just going to rewrite all of this. So it was 4, 5, 8, 8, 9. That's a little bit better. And I just want to make sure that was the correct, and it wasn't correct. It was actually 2 8s. There you go. And then you want to do 3, and so on and so on. All right, now I've completed my stem and leaf plot. I could have done a better job. Towards the end, I ran out of space. And I made sure that I counted everything, so it has up to 22. And the beauty of stem and leaf plot is that you can see the distribution of the data really well. You can see it's sort of, so you should imagine this sort of sideways. So turn your head 90 degrees to the side. You can sort of see it's got a fairly it's sort of like this sort of distribution that you have here. So that's easy for us to see, and that's what we use the stem and leaf plot for. And next thing we want to be looking at, and which is the last thing for today, is histograms. So histograms look like this, bunch of bars, but different to bar graphs and column graphs. It has no gaps between the bars, and we can group things in histogram. We don't always group them, so it's pretty useful. Histogram, you see it everywhere. And on the vertical axis, so upside down, it's this way. Horizontal is this way. Vertical axis, we've got the frequency on the histogram. That's what we want to see. I'm missing a E there, somewhere here. Should be frequency. And on the horizontal axis is the values of variables. So, and each column corresponds to one value or one interval if we group them, and the height of the column, so like how high it is obviously going to represent the frequency. So starting off, so there's two types of histogram, grouped and ungrouped. So starting with ungrouped histogram is when we have these values here on our horizontal axis as like a whole number. So they're not grouped together. And again, we don't want any gaps between the bars. And the next up is grouped histograms. So example is this one here. You can see this first bar represents all the numbers from 0 to 10. So we group them as 0 to 10, and then the next one will be 11 to 20, and so on and so on. So these are grouped histograms. So see how that's different, where in the not grouped histogram, the number is in the middle of the bar, whereas this one, the numbers are on one of each edge of the bar. So that's going to be the main difference. And with these groups, we call them intervals. So when we choose the intervals, we need to be obviously very careful. We don't want to choose just random intervals. We want to make sure that all the data will fall into the intervals that we're choosing. No overlapping between intervals, so you can't do 1 to 5 and then 4 to 7, then the 4 and the 5 would be overlapping. No gaps between intervals, so don't go 1 to 10 and then 12 to 20. So then you're not including 11. And generally speaking, we want the intervals to not have a crazy amount of numbers. Depending on your data, but somewhere between, so your data will have 5 to 15 groups. So you don't want your histogram to just have 2 bars, because your intervals are like, well, 0 to 50 and then 51 to 100. we rather space that out so you have like 1 to 20, 20 to 40, and then you have a bit more, 40 to 60. Like that's preferred over just having 1 or 2. So let's do that. So starting with ungrouped data. So this one is going to be an ungrouped data because looking at our data, see the data doesn't vary as much. It starts at 0, only goes up to like 5. So there's no need to be grouping them like 1 to 5 or 0 to 5. Then we'll only have like 1 bar on our histogram. And then we just count how many there are for each number like this, and then we can put this into a histogram. Now it goes from 0 to 6, and this was about number of siblings, so we want to make sure we're labeling. So this vertical is always frequency, so let's write frequency here, and this is number of siblings going that way. Actually, we don't need arrows. I mean, we can have arrows, but we don't necessarily need them. And what we want to do is making sure that our scales are appropriate. So we're going up to 6, and the lowest frequency is 1, highest frequency is 7. So we don't need to be going up to like 50. We just want to go up to 7. So this is going to be a nice and easy one where we're just going up by 1, because we can easily fit 7 here. Like this. And number of siblings, we want to go 0, 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5, 6. And then we know there were 6 zeros. Oh, it's really hard to do straight lines on the stylus. So this will have to do, but yours should be more straight. So 1 has 7. Making sure the width of the bars, oh, this is really difficult. Okay. Do over. So using a ruler and doing this on a piece of paper would be much easier. I'm just going to wing this a little bit. I don't think it's possible to do this properly. So the width of the bars are important, making sure they're straight lines, making sure your bars are landing in the numbers in the middle of your each bar, and making sure there's no gaps between your bars. And more I'm doing this, more depressing it's looking. Please do a much better job than how I am doing this now. And 2 and 1. So it's sort of like that. Again, you can see the distribution of things really well. This is obviously skewed to one side. And yeah, you can also see what's the highest frequency. So histogram, very useful when we're looking at data distribution. Now this next one, we're given this data. This data looks crazy. It's not even ordered. Very ugly, but we can still use it obviously. This is about the height of basketball players. In centimeters, there's 41 players. There's a lot to count. Given that it's not in order, we need to order them, put it into this frequency table, and then do a histogram. The first thing you should do is to find the lowest and the highest. The lowest here, I think it is this one. And the highest here, I think it's this one. Then you know you have to start at 170, go all the way up to like 203. Meaning that this is going to be grouped. You know that from knowing, well, you're not going to go up by 1 every time all the way to 2 or 3. That's going to be way too many. So you should be grouping them. Then next thing is to think about how to group them. I think this one, because we're going like roughly 170 to 205, every 5 could be good. So 175 and then actually like 4.9 and then 175, then 180, so 179.9, 180, 184. Yep, this will give us about like 8 intervals, which is solid. 8 is pretty good. So we should be doing that. So let me write that down. So like this, and then you should count them. And I already counted. So then you just write down how many there are for each one, making sure that they add up to 41. And then half the work is done. And then we put this into a histogram. Because we group the data into intervals, well, first thing always is to write the labels. So this is height. And also you want to include the unit. If we're doing height, obviously we want to know if it's in meters, centimeters, millimeters, or whatever. So we want to put the unit there as well. And we know the lowest frequency is 1, highest frequency is 13, so we need to go up to 13. So we're not going to be going up by 1, because there'll be way too many. We don't want to be doing 13. For this one, let's go up by 5. I think that's reasonable. 5, 10, 15. I think in hindsight, maybe going up by 3 is also good. 0 here. And we are not starting at 0 for the height. We're starting at 170. And the next one starts at 175. So you write it like that. See how it's 170 and the next one's 175. So within this one, there's 4 people. So we go up to 4. So we start at the start of our scale. Oh, that's too many. Go up to 4, which is just below 5. And we end like that. So that's going to be the first bit. And then another one we need to do here is because we're skipping some numbers here. So we don't start at 0 for our height. I just realized I spelled height wrong. Missing an E here. We're not starting at 0, so we should put that sign there indicating we skipped some numbers. And then obviously the next one is going to be 180, making sure the gaps are about equal, each one. And there's 5 people within this one. So it's going to be like that, making sure everything's straight. And you complete the rest. So it should look something like this, but more straight, gaps are more equal, that sort of stuff. Now, this was really painful to count each one, obviously by hand. So when we have a large data and it's not ordered, it doesn't come in a frequency table like this. Like if it comes in a frequency table like this, it did the half the work for us. So we can easily put this into a histogram. But if we have to do this process again, which personally I wouldn't want to, we can use the CAS to do it for us, and I'll show you very quickly how to do it. So make sure you grab your CAS now and actually try this out, because just watching it won't cut it. You will not remember. So here we've got 27 data, not ordered, very ugly. We're asked to draw a histogram. Let's use a CAS to do it. So you open up your CAS, it'll probably look like this. Where we want to go is this green one here, gives you like an Excel spreadsheet. First thing is to go up here, and this was about marks. So let's name it marks. So that's labeling our things, our variable. And then in no particular order, I'm just gonna write it in the order that's given to us. We simply just write down all the numbers in. Oh, how did I? Interesting that it just took me there. Going back here, we're writing the numbers. So in no particular order, just simply going down the list, you're just putting in the numbers. So let me just pause. So I put all the numbers in. We're at 27, which is great because we're given 27 marks for this. The next step you want to do, you want to press Control and you want to press this document. And see that little page sign that's in that blue color? That's what it's going to do because we press Control. So it's going to add a new page. And it looks like this. And the page we want to add is not calculator, not graphs. It's actually this data and statistics. And then we've got this. Now, let's turn this into a histogram. So first thing I want to do is, we know in a histogram the marks are going to go down here. So we can either click here or here. We click here and we choose marks. First it gives us the dot plot, which is also kind of useful, but we want a histogram. Then we go into menu, we want to go into plot type, choose histogram, and then it gives us the histogram right away. So it gives us the intervals that is most appropriate. Here it's every 2 numbers. And each of these, if you go over it, it tells you like the frequency as well. You can also see the frequency over here as well. So that's very useful. It's, I think, much quicker than counting all this and putting them into order and finding the intervals and all of that. So you can just simply put them in no particular order and let the CAS do the work for you.